Generator to breaker panel connection, Honda EU7000is. If I understand correctly, I can connect a 30 amp cable from outlet 1 and another from outlet 2 and connect both to a single hot bus at the breaker panel. Correct. See attachment page 39. Site won't allow PDF upload, file too large. Here's a link, http://www.electricgeneratorsdirect.com/manuals EU7000is %20 manual.pdf. BTW, this is for a mobile application. Conflict with utility/shore power is not an issue.
Welcome. My name is would be glad to assist. Can please elaborate on the question? You want to use both of the 240 volt receptacles from a single generator to a single breaker? 120V/240V position. When the voltage selector switch is in the 120V/240V position, you must balance the load. Divide the load between the two sets of receptacles shown below. Balancing is necessary because each set of receptacles is powered by only one power-producing circuit that can produce a maximum of 22.9 amps. Is that what you are referencing? Let me know and we can continue, thanks.
I want to run the full 45 amps at 120 to a hot bus in a breaker panel and break it out from there. Number 240 needed. The manual seems to indicate that when in 120V only mode it balances the load across terminals 1, 2, 3, and 4A. Since 1 and 4 can take a 30 amp plug, can I connect both to a hot bus at panel?
Okay, thanks. With generators, the power from each receptacle is not additive. When connecting one receptacle's power to a single breaker and then adding another receptacle to that same connection, it will not increase the amperage. Only when you connect separate items to each of the receptacles on the generator can you get the full amperage. The maximum amperages for the breakers are shown: 130A at 120V, 220A at 120V, 320A at 120V, 4A, 30A at 120V. So, you can connect the receptacle 1 to the breaker and get 30 amps at 120 volts. But you would have to connect any other receptacles on the generator directly to the item you want on the generator. It cannot be connected to the same breaker or the panel. It will not increase the amperage. The receptacles do not add to each other. They each have their own maximums individually only. Let me know if any clarification is needed, thanks.
Except Honda lets you connect two generators with a cable to double the power, because they will run in sync. So how does that work if I can't add two receptacles? And since the manual says no layout balancing is required when in 120V mode, as long as no outlet is overpowered, that means I could take 12 amps out of the outlets 1, 2, and 3, which is more than the 23 amps of circuit 1, so there is some internal balancing ability.
Okay, with two generators, you have special generator panel that connects to both generators. For parallel operation, use only a Honda-approved parallel kit, optional equipment. See page 81, when connecting one EU7000is to another EU7000is generator, so both generators connect to the panel and then the panel has a connection to the home panel. The kit will keep the generators in sync, so that the maximum power can be obtained at all times from either of the two or both. The parallel kit has special controls to perform this function, and without it, they can only operate as single generators. Thanks. Okay, let me explain, you posted, and since the manual says no layout balancing is required when in 120V mode, as long as no outlet is overpowered, that means I could take 12 amps out of outlets 1, 2, and 3, which is more than the 23 amps of circuit 1, so there is some internal balancing ability. That is only when connecting a cord to the receptacles, then connecting the other end directly to what you wish to run, like an appliance, TV, refrigerator, furnace, etc. It is not for connecting to a panel in parallel. Electricity does not work that way, they do not add to each other. They are from the same source, it isn't possible. They each have their own breakers for using individually, not collectively.
I've looked into that. The only thing special about the kit is a second wire that connects from the output of generator 1 to a special input port on Gen 2. This allows the second generator to read the source generator phase and start up in sync. After that, it just joins the hot cables together. On a single Honda, both generating circuits are already in sync, which is why there is no balancing required in 120 mode.
Okay, look at what the manual states. I think what you may be missing is that the statement below is only when using receptacles connected directly to a single item by a cord, not to a panel and breakers. 130A at 120V, 220A at 120V, 320A at 120V, 4A, 30A at 120V. Read more. http://www.justanswer.com/expert/qa.asks. SRC equals PQL and so equals 1 and T equals 150559049 ZLUGML 120V only position. When the voltage selector switch is in the 120V only position, you do not need to spread the load over the receptacles. You must, however, make sure the load on any receptacle does not exceed its available power shown in the preceding table and the total load does not exceed 45.8 amps. Maybe this is a better way to understand. Let's say you have a stove to connect in the house. You need 40 amps to run that stove. So, you take a cord and connect to a breaker in the panel that is 20 amps. You then connect another cable to a second breaker at 20 amps. You now have two 20 amp breakers connected to the stove. Is this 40 amps? No, it isn't. The stove will not run, because there is actually only 20 amps available. The breakers do not add together, they provide power singularly, not additive. Same on the generator, each of the receptacles can supply only its maximum power just like the house panel. One power source. This is why the generator has two phases of power inside. So when using the receptacles you can get power from both sides to run items connected directly by cords. One phase has 22 amps, the second one has 22 amps. Those two phases cannot be combined with each other because it will cause an explosion. Like shorting out the two legs of power in your main panel. Look at your main power into the house. There are two power cables, they work separately and cannot touch each other or they short and an explosion occurs. The generator only has maximum power when using both phases, not one.
What you're saying makes sense, but then I don't understand how two 15 amp lines from two generators can be combined to create a single 30 amp line, but the Honda parallel kit does that, so what am I missing? I am aware that some parallel kits also provide overload protection with a master breaker at the max amps, which I could include in my plan, but it seems they are still adding amps by joining to lines. So how does that work? Here are some kits and examples: www.wisasales.com/triple-parallel-kit.html http://www.gentran.com/eshop/10expand.asp Product code equals 6370C http://www.electricgeneratordepot.com/Honda U2000i home parallel kits /www.youtube.com/watch V equals QChem10_3T_W https://www.youtube.com/watch V equals WMCHF EMLU.
Okay, they combine, because they have added equipment to perform a very difficult task, syncing generators. The additional equipment has the ability to sync the two generators so that they act as one. What you want to do is try to get one to act as two. That is the difference.
The GenTrack page has a couple of reference docs.
Okay, again, it is the specialized equipment, parallel power kit for Honda EU3000is. Purchase a connection kit and you can get a second generator and join them together. But using one generator, no matter who makes it or how you wire it to your panel, you can only get what the generator can produce off the phases of the generator. All generators are the same. It is physics.
So the output from two generators can be combined but not two outputs from one. But if I can connect various loads across all outlets without balancing them, as in the 120 mode, aren't they already in phase?
It is impossible to combine outputs with electricity, period. No matter if generators or in your house electricity. I showed an example of that earlier. It is all the same, what you have at the beginning is all you can get. The generator will not produce 45 amps on a single phase of power. It does it with two phases of power. You need to understand the difference of using cords to each receptacle will use both phases. When you want 120 volts, you only can get one phase of power. The largest one on the generator is 30 amps. That's all you can get no matter what you try. You can connect them up, but what will happen? The large output trips at 30 amps, the other two will trip at 20 amps. So, how can it deliver more? Manual gives you this also. 120V only the 120V receptacles can be used. Do not use the 120V/240V receptacle in this position. The most power will be available at the 30A 120V locking plug receptacle. So, that is the most you can get on 120 volts connecting to a breaker.
I must be missing something. What you are saying is I cannot combine current that is not in phase. And the dual output of a single generator will never be in phase. Is that correct? Two generators would clearly not be in phase, so if they can be combined with a kit, then the kits adjust the current to be in phase, yes. So if I run receptacle 1 and 4 into the kit, it should then, theoretically, sync them in phase. Page 38 says there is power at receptacle 1, 2, 3, and 4A in 120 mode. Obviously it can't meet the max of all of them at the same time, but it should be able to meet 23 amps at receptacle 1 and 23 amps at receptacle 4A, so a parallel kit should be able to bring them into phase.
http://tinypic.com/r/2z3 of 6q/8 copy and paste the link, maybe it will help.
I think I understand what you're saying. Was I correct about needing to be in phase to combine?
Okay, with a single generator, you have two lines of power, called phases. Each phase or line can produce X amps, in your case the maximum of 30 per line or phase or total of 45 on the generator, or else it will overload and heat and eventually burn up. The Hondas are special inverter generators, and when they are joined together like twins, the power lines will be the same. Two legs on each of the generators. One leg from each generator will be in sync with the other generator. So, those two will be as one, running exactly at the same frequency. Same with the other two, they will be in sync. So, you get 30 amps on one plus 30 amps on the other, for 60 amps maximum. Or only 90 amps total with two generators. But even then, you see you only get one side, you still do not combine the two phases or legs, they are still separate, you just doubled each side, nothing more.
I just spoke with Honda Corporate Tech Support. They said that in 120V mode all receptacles are in phase. He went on to say that the parallel kits do not provide phase sync circuitry. Does this make sense to you? The manual does say that in 120V you can get 45 amps out, spread across receptacles.
Okay, cover the receptacles twice already. They each have their own breakers and supply lines with receptacles for outputting at the same time to individual items. Breaker feeds are a little different, but if you want to proceed, connect to the 3 receptacles and see what happens. It will be a matter which breaker will supply the power and who will trip first. On the generators in parallel. Yes, the phases do not sync, the generators do. When they sync, they run at the exact same RPM, which makes the frequency of the power the same. That means that the 2 lines of power can be joined together when using 2 generators. See, if one generator runs at a different RPM, it will output the power over the other generator instead of them both running in unison together producing equal power. Like 2 runners, if they are side by side, they are equal. If one runs faster, he will lead and be in control and the other one will lag behind. Something to note, I do not suggest to connect using all the receptacles to a panel. If you read through the manual, you will not find anywhere that they mention to connect to a panel in 120V mode through 3 receptacles. Be prepared for tripping immediately upon connection on the breakers and receptacles.
I understand generators running at the same RPM. I'm not sure how that applies here. I would not use 3 receptacles. I would only use the 230 amp. Is there something different about using 3? I have not purchased the generator yet, so in a worst-case scenario, I could get 2 EU7000is units and parallel them, though I get less power at more cost, but I don't yet quite understand why I can't use the 7000. Is it about phase? Frequency. Multiple breakers on outlets. Or something else. I'm not an electrician, but I'm not an idiot shade tree mechanic either. I do have a master's degree in computer science. Can you explain for someone with some basic electrical knowledge, I don't need running analogies, why 2 in-phase receptacles on one generator cannot be joined when 2 receptacles on 2 generators can be joined? Frequency should be the same. Phase is the same. What is not compatible? I do understand that one cannot connect 2 20-amp branches on the same leg of a panel that only has 30 amp service and get more than 30 amps. But I would believe you could get 30 amps between them with the possible problem of how to make sure it doesn't trip one of the breakers. But that same issue occurs with paralleling 2 generators. If each are rated at 30 amps and you can get 60 with a coupling cable, it seems there is the possibility of pulling too much from one and tripping its breaker. I'm not sure how that is handled, but it doesn't seem to prevent the practice. People are doing it and major corporations, such as Honda, are supporting it. So I've left that question aside.
First, the manual states, you cannot use the 4-wire receptacle when on 120 volts, only the other 3. The 4-wire receptacle is for connecting to a house panel. Now, let me use your post, it may work for explanation itself. I do understand that one cannot connect 2 20-amp branches on the same leg of a panel that only has 30 amp service and get more than 30 amps. But I would believe you could get 30 amps between them with the possible problem of how to make sure it doesn't trip one of the breakers. That is correct and the point of it all. You cannot get more out the main trunk even if the branches are capable of more. But that same issue occurs with paralleling two generators. If each are rated at 30 amps and you can get 60 with a coupling cable, it seems there is the possibility of pulling too much from one and tripping its breaker. Not if they are running together at the same RPM, they are at the same phase angle and each one can supply 30 amps to the same connection point. If they do not run together at the same RPM, then absolutely one will overpower the other and the one will slow down and not produce any power on the line. That is the whole purpose of the extra equipment to join two generators together. It keeps them in complete unison and they will produce equal amperage at all times. This isn't new, been around since generators have been in existence. It normally takes expensive equipment to get that together, more than buying a generator 3 times the size, and that is where Honda has come to play and designed a more economical unit that will keep two generators operating together.
I apologize for the difficulty. I'm not trying to be difficult. If I understand the manual correctly, I can use the number 4 receptacle, as well as 1, 2 and 3 in 120V mode. What I must use, however, is the 3-prong plug of receptacle 4A, not the 4-prong plug of receptacle 4B. And 4A can provide 30 amps, as well as number 1 providing 30 amps. So I could run them as separate legs into a panel and break them out separately. The receptacle limit/internal breakers are not the issue. There is 30 amps available and separate to each receptacle. The problem with running them as separate legs is I'll wind up with stranded power. 3 to 4 amps on each leg available and not enough on either to run a 7 amp load. Moving loads around doesn't quite solve the problem because some loads are intermittent, some are rated loads, such as refrigeration, where I won't know the actual running load after startup until I connect it, and in other cases I'll wind up having to split the branch circuit down both sides of the truck or crossover. Once this is done, pulling new lines won't be fun. I don't quite understand the RPM issue. There might be issues with different RPMs and power between two generators, but we're talking about one, and in an inverter generator, the inverter switching should determine the frequency, not the RPM. RPM could affect the total power output, but shouldn't change the frequency or voltage, unless RPM drops so low it couldn't maintain voltage. So I guess the question is, how does one combine the current from two in phase, same frequency sources? If two generators can be combined, there should be a way. Smile.
Okay, first, RPM is only when operating two generators, so it is not part of this discussion with a single generator. It was only brought up because you asked about how two generators work. I do not have any information that I felt will be any better examples than what has been posted. I will be glad to opt out of the question and allow for the other experts to provide what they can on the situation. That is about all I can do. You cannot combine same phase power through separate circuit breakers to an end source and achieve more amperage than the highest output of the system. If that could be done, we could buy 5 kW generators and produce 10 kW of power. You can use separate cords plugged into the receptacles and achieve more amperage, because they will supply different end sources. You can actually overload the entire generator that way with 60 amps if wanted. That is about all I can provide on the situation. Let me know when I can put it back on the open board. Thanks. Just for clarity, if you have a 100 amp main breaker panel, and inside that panel you have two 40 amp breakers on the same phase, you can connect both 40 amp breakers to something that needs 50 amps. But you will only get 40 amps out. Same thing, all electricity is the same. You can, however, Connect those two 40 amp breakers to two different receptacles and then you can power two different items with 40 amps each from the receptacles.
Your last two don't seem to be saying the same things. When I'm not trying to use a 30 amp source, breaker into 30 amp branch circuits, and then add them to get more. Obviously breakers have nothing to do with how much current is available. The 7000 is a 45 amp source with two 23 amp branches. I'm trying to put them back together. Your second example said I could get a 50 amp circuit, but I would never get more than 40 amps. Not clear. I think you're saying if it's a 100 amp service, and I break it into 40 amp branches, I cannot connect two branches to get an 80 amp line. Maybe this is where my error exists. I thought I could connect them to get 80 very much like it's like putting two batteries in parallel. I have not increased the power through breakers, I had 100 to start with. In fact there was 80 or 100 all along, assuming the wire could handle it, except the 40 amp breakers would interrupt it. The breakers don't add power, but they don't reduce power either. They simply interrupt at a given point. So I guess I view two 23 amp in phase outlets on a 46 amp generator as two circuits on the same phase leg in a panel. They won't add. Then why the heck would two different generators add?
Okay, give me some time and we'll try once more to write up the situation. Going to take a while, so please just be patient. Thanks. Understand, AC power is not like DC power with parallel, amperage, and series, voltage, connections, so we will not get into that. There is no relationship at all. First statement, just for clarity, here is your generator. 7000 watt surge / 5500 watt continuous 120/240ths of a volt 7000 watts max. 58.329.1A 5500 watts rated, 45.822.9A, it is not a 7000 watt generator, it can withstand up to 7000 watts in surge situations only but cannot maintain 7000 watts. This is for items like motors on refrigerators, air conditioners etc., which when started, have amperages 3 to 5 times their normal for a second or so and then drop off to normal. Your generator is rated at 5500 watts continuous, and that is the load you can put on the generator to operate full time. Maximum. Second statement, your second example said I could get a 50 amp circuit, but I would never get more than 40 amps? Not clear. Dash when a generator is connected and the load needs more amperage as other items start or stop etc., it will try to get that amperage from the generator. It doesn't matter what that is either, 5 amps or 100 amps, it is going to try and get it. The generator, in turn, is going to rev up as high as it can go and it will try to deliver the amperage. That is its design, to deliver what is asked for at any time. As it revs up, it is going to either, 1. Trip the breakers that are over their amperage rating. 2. Shut down because of overspeed, 3. Burn up the generator windings. In the meantime, as it revs up and tries, the amperage is over its capability and now the voltage drops on the output to a voltage level that is inadequate for anything to operate and can cause serious damage. There is nothing to stop it from trying to deliver the amperage except the circuit breakers on the generator on each individual line, that is the first line of defense. After that, the safeties in the generator itself are the only items. So, now we have the generator operation, let's go with the 2 power cords to 1 main feed in a panel, let's rephrase the situation and look at it from a standard parallel situation. Of course with any generator you must have an interlock installed to keep the utility side away from the panel when the generator is running and vice versa. and protect the overall input to the panel. You can parallel wires from the same breaker in electrical wiring by code, so let's look at it as two breakers instead to help understand the issue. Let's say you connect the 30 amp 120 volt and a 20 amp 120 volt line to the panel. That is called parallel, and it is against all codes to parallel with wires less than number 10 in size even using the same breaker. Why? This is because of the unbalance of the wires in smaller sizes. Can you control the resistance on the two separate breakers and wires and balance the amperage through each one? No, so look at this way, one wire can be pulling 10 amps and the other is pulling 8 amps. All is fine, then you increase the load. Now you need 40 amps total. 22 more amps than the 18 being used. Which wire is going to pull the extra needed amperage? If it is the one off the 20 amp receptacle, it is now going to trip the circuit breaker on the generator. When that happens, the 30 amp is going to carry the load, and since it cannot carry the 40 amps, it will trip. Now you have no power at all. There is no way to control how the amperage will be distributed. It will follow the path of least resistance at all times. When you have two generators connected together, they follow each other and become a single source of power with one power line to the panel, up and down equally sharing the load. Copy and paste the below to read up on parallel generators. It is good right up. http://www.dieselserviceandsupply.com/parallel_gensets.asks. So, if you wish to connect two lines to one location, then you can experience the difficulty of balancing the load. Might be able to actually do it with different wire sizes and measuring the resistance beforehand and adjusting to get them equal. But once power is applied, it will change and then you have to make a change/adjustment to compensate. That is why it is not done. Best I can explain. Thanks.
I can see the imbalance. That makes sense. With two generators it is regulated. Thank you.
Okay, very good. Glad to assist on the situation. Thanks.
If you have a home improvement or appliance question and want to chat with an expert now, visit JustAnswer.com/YTHI.